Hello, scholars. This is Mr. Benzel here, and we're going to be doing Skill 5 today, which basically is multiple representations of graphs. And we're going to be looking at when do we use certain types of graphs, and you'll get to see the different types of graphs that are on the SAT. So some key features of graphs that you should be kind of paying attention to is the title of the graph. This is kind of like the general subject of the graph. And then you should be paying attention to what the axes represent. So this is sort of what we are comparing in the graphs. And then we are also looking at the scale as well. So the numbers are important and they can really tell us what they mean. And I'll just say that that is the scale. So even without, reading like the specific trend, there's a lot that you can gain in the information about the graph. All right, so we're going to see about 4 major types of graphs. So the first type of graph is what we call like the bar graph. So the bar graph, I'm just going to be very rough. I just want to kind of show you, what they look like. So that's what a bar graph looks like. And the sizes of the bars are related to the quantity. So I may be asking, how many people like red or green, stuff like that. Dot plot is actually only one axis. So this could be like, test score, for instance. And this gives us just like the overall frequency. So maybe if I have, I'm just going to kind of do basic example here of like 80 and 82 on a test. So maybe 2 people got 80 and 3 people got 82. This is how the dot plot is created. And then the histogram resembles the bar graph quite a bit, except you're having a range of values on the x-axis rather than a scale. So maybe I'm looking at like 30-year-olds and 40-year-olds and 50-year-olds and stuff like that. And then the line graph is usually like when you have over time, and you get to see like how it trends over time. So maybe I'm looking at temperature and time during the day. So it gets to be like the low temperature in the morning, and then it gets hot, and then it starts to cool down again. So it just shows us how the quantities change over time. Particularly with line graphs, we have some keywords that can tell us. So if you see these keywords, you can expect, the graphs to look a certain way. And then sometimes with the way that graphs look. So if we see increases, grows, or rise, we are talking about a positive slope. And if we have decreases or declines, we're doing a negative slope in that case. And they could be curvy or they could be straight. And then zero slope would be remain constant. That would be like your horizontal line. And then slowly or gradually, that is kind of a slope that's not very steep in the positive or negative direction. So and then rapidly or quickly would be a more steep type of slope. So make sure you have that chart copy down, because the keywords can tell us what the graph is going to look like, And then also you could even look at things like slope in the graph and how steep and come up. So like you could come up like saying, okay, this graph here is increasing slowly, stuff like that. All right, so let's take a look at an example here. This is a school enrollment graph. So the question is, what is the general trend? Is it increasing or decreasing or staying the same? So we could say that since the slope is positive, school enrollment is increasing. And then it says between which year saw the least amount of increase. So we are looking for the flattest portion of the graph. And I'm just going to kind of circle where that is. So it is right about there. So we would say that it's between 2017 and 2018. All right, another problem, you could kind of do this type of analysis with a bar graph as well. So this is showing the number of women in a Congress. So we have like 2-year periods in Congress. So 1989 to 91, and then 97 to 99, and so on. It's the 105th Congress. So every midterm election is going to get you a new Congress. And the question is asking the number of women saw the greatest increase between which years. So we could see a huge skip up between the 102nd and 103rd. Making the answer choice B. Oh, and then this one, this is a graphical analysis. And we may want to think about, so it kind of gets a little nitpicky here. It says daily rainfall in centimeters was recorded in a 41 period in Turramurra. For each year, the day with the most rain in centimeters was plotted above according to the rainfall to the nearest 2 centimeters. So each dot represents the maximum day rainfall total in a given year. It says, according to the dot plot, what is the maximum amount of rainfall that was ever recorded in a single day? So we would kind of look at the highest value here. So we would say that it was about 38 centimeters. We will have some time in class to discuss problems as well on the SAT. And I'll give you like some graphs, and you'll want to be thinking about what does the axis represent and what is the graph about. And then the SAT likes to ask, what do the intercepts represent on the graph? So let's take a look at this situation here. So instead of saying that this is an XY coordinate situation, they're calling this the YI plane, where years are on the x-axis and interest rate is on the y-axis. And it says that accounts for lasting a 1 year, less than a year, are short-lived, and accounts lasting for more than 5 years are long-lived. And we're finding the interest rate. And what this is saying, so if we kind of look at this, it shows the interest rate one can expect for a savings account lasting Y years up to a maximum of 10 years. So we're looking at the I-intercept. So this is a 6% interest rate. So obviously things that don't have 6% in the description, we can immediately eliminate. So it's either going to be short-lived accounts have a minimum interest rate of 6% or long-lived. And obviously, since T is close to 0, it's short-lived. So we would choose answer choice A. So I think it's very important to kind of just read the axes, indicate what it means for something to be an intercept, and then you'll be able to answer the SAT question pretty well. Now, come with me to some Delta math, where we will get some practice creating histograms. So your Delta math assignment tonight is going to be focusing on interpreting graphs, and then also you'll have the opportunity to actually create a histogram as well. And I'm just going to kind of show you how this works. So I'm going to go to create histograms, and we're going to see what's going on here. So this is the Fahrenheit temperature readings on 60 spring mornings in New York City are summarized in the table below. And it has temperature and number of days. So one thing that we notice is that the temperature starts at 20 to 29. So we're not going to start at 0. We're going to start here. And we're going from like 20 to 29. And it tells us that it's going to be 2 days. So I'm just going to go 2 high. And then we'll just label that 20 to 29. And I'm just going to go kind of a width of 2, because I think I could pretty confidently fit the 6 bars or so. Then I have 8 days that are in the 30 to 39 range. So just click and make the bar the same length. And we have 8 days in the 30 to 39. And then we're going to go to 40 to 49. So we're going to go 18 for that. So I'm going to go look for 18. And then I'll label that 40 to 49. And then I have 24 days for 50 to 59. And then I have 6 days for 60 to 69. And then I have 2 days for 70 to 79. And the key is that you just want them to fit on the graph. And just have enough space, and you want to keep those widths the same as well. And then we're good. Actually, they went with a little wider width, but as long as you are keeping the intervals the same, that is good. So that is going to be the unique type of problem you're going to see on your Delta math tonight. So thank you very much for tuning in, and best of luck in your graph creations today.